Okay. And if you click on that link, you should be able to see what it says here. And by the way, somehow my camera is not perfect. I wonder if I can clean it a little bit. Yeah, I think it's better, right? Okay, so especially if you haven't been here, that link allows you to see everything that's going on right now and everything that has been going on right now going down. It started maybe about half a year ago, and I would call it a seminar. We use the term webinar just because people are used to know that, webinar is when people meet on the web. But I prefer, especially in the quantum computing, where there were seminars, if you read about the physicist and about how Oppenheimer had his seminar for his students, I'm really thinking about the same thing. Perhaps, well, surely for I'm not Oppenheimer, but the ideas are the same. So that is what I have for today. This here, we'll talk about quantum computing as specific cases. Usually what we do is talk about anything that comes up. Maybe the news, maybe there was some practice. And if you go down, you'll see that we discuss books, we discuss how you can learn quantum computing. Somebody actually came up with a question. He said, what would be the best way to learn quantum computing if I'm starting from scratch? And that is what we did last time. I gave you the lists and the videos where you can start, all your resources. But it is an amazing thing. I wonder if you will agree with me that quantum computing is so deep. You can learn it on many different levels. And here we are, we were looking at, you can look at it from the point of view of mathematics or physics or quantum computing and probably more. But at least three of these views. So that's what we covered. Today, however, I'm going to talk about what I discovered very recently so that it will be interesting to everybody, or at least everybody who is interested in the latest and greatest. And let me start. You guys see the screen, right? Let me do one thing. Let me close that, and then we're clear. So, and let me watch. Yeah, thank you, Mark. Let me watch the chat if I can. But I don't promise to watch the chat. What I do promise is to hear you. So when you say anything, then I'll be very happy to hear and maybe answer. Okay. So this time I was very interested in quantum computing and logistics. Now, you will be laughing maybe, but I have a very vested interest. I'm involved in one last mile delivery company. Really, they don't think of themselves as such. They think of themselves as first choice messengers of Texas. They are a delivery company, but I'm trying something unusual with them. I want to turn them into most advanced, forward-looking, blah, 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 delivery company and claim that delivery today is extremely important, extremely technologically challenging, and that was my interest. Now, you will be surprised to see the people who I'm dealing with. These are really good guys, Texas farmers. Most of them, and I think all of them, hardly graduated from high school, and they don't need it. They usually on the truck, and they usually do deliveries. So you would think, what has quantum computing to do with it? But it does. So let's go. I'll show you what I found out. First, we'll go here. That is, but I found a lot more. I found a lot more and interesting things. So that's why I promise you it will be interesting. So here is exploring quantum computing as logistics. And logistics in this case means that we're jumping into the truck and delivery. Now, they talk about how important that is. And they build up the case first with guys, you need it, and you will gain a lot from that. That's where it all starts. So, quantum insights into delivery business. This is called the last mile delivery. Of course, this meaning is that after all container packages, Maersk, maybe technologies, and going over the world comes to the Texas farm. And somewhere somebody has to deliver it there. And there is a lot of game changing potential in this very mundane thing. So, what is it? Well, that's what I wanted to find out. And number one is that exact use case. What they say is that you will be surprised, but it's a technology problem. How to best optimize the delivery landscape, and keep in mind that there are many changing things. That's where they start with. There are many, like they refer to a certain commercial vehicle manufacturer who optimized through a combination of classical and quantum computing and delivery operations. Now, that's a classical computer problem, but it's well known that there are many problems where there are no solutions. One of such problems is container and packaging the containers into given shapes. And that is too many combinations to go through. But practically, we don't go there because you might build any kind of theory, and I will show you the theory. But you don't need the best, you need only good enough. So what you then do is you combine the classical computers and quantum computing. That's not a new approach. I have already seen that Intel is doing this, so maybe it will be a way to go, the way into the future. If you look at IBM, what they do is concentrate on cloud computing, cloud quantum computing, and only that. They are not into classical plus quantum. They're only interested in quantum. And if you are studying quantum computing with them, that is probably the best. They are the thing, but maybe it's not the most practical approach for all over. So that's first. That's step number one, that there is a quantum computing for delivery. But I found out much more because when you look at that, well, you think, university paper at most. No, let's continue. That's the use case. Now, all these links are leading one to another, so you wouldn't be surprised if you will see it yourself. It took some digging before I found the most amazing, what was the most amazing to me. So, okay, that's the same thing in more detail. The first article that meets your eye, that was IBM website. This article is a link from IBM website. And they're essentially talking about the same thing. Now, that may be too small, but I'm telling you the major points anyway. And they, first of all, brag their credentials. Then they give you the executive summary with the same idea, last mile delivery, game-changing potential, that if you take even 1% over 400 million, it will be a lot of money. Well, my personal opinion, of course, has nothing to do with quantum computing. But if you keep reading, you will want to know what exactly is quantum computing algorithm as it applies to delivery. Well, for that, that article won't be any use. If you need these articles, they are found in the same place. Let me show you where everything is found. So that's our, oh, that's not advances in AI, that's our QC. I think it's the same here. Yes, that's this one. And that is the folder for all the seminar materials. So if you go here, you'll see all of those materials that we mentioned, and anything that you need is here, and even some books that maybe are not supposed to be downloaded from the web, like the best and greatest book on quantum computing. We talked about this. It's called Mike and Ike. And it's here. The PDF is here. So let's close that. Let's go back here and gradually building our use case. Let's go to the actual algorithm. That was all. That was all I was showing you. They talk about the basics of quantum computing. And from there, you can copy paste any kind of quantum computing stuff. So that doesn't give you anything other than repeatedly using this last mile delivery as a use case number one. So we need to look at that and you will find it. Once you go down, you will see there is an article mentioned. The article, I also have the link to it right here. So I'm going back. The article is QUBO, Cubo, I would call it this. And that's now the real stuff. Now, it's not very convenient to read it here. So I close it here. I prepared it here on the desktop. That's the one. And I will make it somewhat bigger, as big as I can. Let's see. Yes, that's better. So that's an article of 2020. Now, that shouldn't bother us because it's not the latest word that counts in quantum computing. The best book was written in 2000, and it is still the best book, even though it's Michael Knight, even though it was written when there were no computers. But nevertheless, it said everything so correct that it's still the best and best seller. So here too, 2020 is no problem. And what they will describe is a potential solution looking for the problem. That's one of the characteristics of quantum computing. We have some solutions, and we feel that they will be great, but not always the most practical solutions. This one is called quantum annealer. And quantum annealer is an optimization problem. So we come to some reasonable problem that you can solve. It's called quadratic unconstrained binary optimization. That's just a bunch of nice words. QUBO, okay? And what they do is this. I think there will be a picture. Well, if not picture, there will be formulas. But I'll tell you what it is about. You're trying to package your deliveries in the optimal possible way. And it's a well-known NP-hard problem. It's not solvable completely with a classical computer. So instead, what you do is formulate it as a quantum computing problem here, a minimization problem, and on goes for real stuff. But we see that the input data that they're dealing with here includes containers and tracks. Now that makes sense because we're doing deliveries, we're taking containers and delivering them on the tracks. Okay, so we see that, then we find out what will be a quantum computing algorithm. They don't give you a quantum computing algorithm the way IBM usually presents it. They're using Qiskit, but instead they talk about theoretical optimization problem that you could solve on any quantum computer, solving the Kubo problem? Well, and here is where you discover the surprise to which I was leading. It's the D-Wave system. So D-Wave is a certain computer. It's a certain quantum computer. It's not one of those IBM or Google, but it's a new company, and that is what I'm going to show you. So to solve that, we'll need a D-Wave system, and D-Wave system is part of a, amazingly enough, large practical quantum computing company that is interested in practical applications of quantum computing. So I'm going to still discuss that on the Qiskit Slack, because once I asked them, so what are the practical applications? And they said there are none. Well, according to this, there are, yes, there are solutions, and we'll come to them. Now, theoretical part of it is here. It's quantum annealing. It's produced by a Quant D-Wave system, which is a company. We'll go to that later. And that adiabatic evolution. Wow. But in any case, there is a algorithm, there is a problem stated, and a solution, and even a computer's name. One very interesting thing is something that you have never seen. Look at that. So it's the most developed D-Wave 2000Q has 2048 qubits. Now, for comparison, tell me please, what's the best IBM computer? I'll go back to the chat. What is the best? The best meaning the largest. Yes, Randy, absolutely right. I finished answering asking the question, but you already answered. Now, compared to that, how do those numbers look? 2048 qubits. And they, Chimera, they even name the architecture. They say that is real. So that really provokes a lot of curiosity, doesn't it? Yes, it does. So therefore, we have the use case. We have the article by people in Holland, one of my favorite places. And therefore, we need to research further. Let's continue. Right here. Let's go to this company. I went to that company, and that is what I saw. Oh boy, that is login. Well, I can log in. I think I can. Let's see if that works. That's probably my email, right? Let's try to go into my email. No. Yes, indeed. And there you are. We are inside of a quantum computing company where I created an account, and not only an account, they claim to give me quantum computing time for free. Of course, you can create an account then later on in earnest, but it starts with here is your calculation for free, and what we give you is a D system. So to me, that was an enormous surprise. It was yesterday I found out that was a actual company uh, doing all kinds of quantum computing, practical solutions. And then it made sense. Suddenly it came together. That was promoted by IBM. It was the use case that was promoted on the IBM website. So it began to make sense. And that is not the first time that happens in quantum computing. You can learn and relearn in the same book. You can do it quite a number of times. And every time you will discover something new. So that is, I think, the most interesting part of knowledge and most interesting knowledge of today. Yes, we have AI, and that is great. And there's another seminar, security. All of that is very interesting. But it never stops surprising me that you find something incredible that you didn't even know. All right. Well, we want more. We want to know who they are. We want to know where are they in the world, so to say, and we want to know what's the real story. These are computers, and I have access to them, and they promise all kinds of resources, as you can see, a well-developed website with a lot of resources and community. I even left some of this investigation for us together. Maybe you will be asking questions, or maybe you will be adding some of your knowledge. And then look at community. And here's the community talking about, so it's real with the API. So let's continue investigation. That's not the end of it. Let's go back to our seminar and let's look at that. That will tell us about D-Waves system. Now, as it turned out, it is a public company. We'll go there. The Practical Quantum Computing Company. Now, guys, tell me, have you ever heard about that company? So what I will do is I will check who is here. I will allow everybody to talk, and I will ask that question. Is that a big surprise to you? Okay. Here you go to the chat. That a surprise to you. There you are. That's my question. Question mark. Since nobody says anything, then I would say yes. Because if it was not a big surprise, if you say, oh, I do this all the time. From what says Mark? Okay, it's one of the first companies. Yes, and then I find out that they are born in 2000. So Mark, for you, it's not a surprise. For me, another Mark, it was a surprise. For all others, I'll assume it is a surprise. So I continued investigation. I wanted to know about them. I signed up. I have access. All right. How can it fuel operational excellence today? Well, maybe I should download, but let's look at the company. Yes, you are practical, but you're also a public company. Now, its symbol is not D-Wave. Maybe D-Wave here will tell me something about, or maybe investor relationships, but it doesn't matter. Okay, investors. There seems to be a confusion between, there are two D-Waves. That couldn't be. So it's probably naming and renaming. Ah, that's the symbol. So find that symbol and let us go to finance. google.com, and find them here. UBTS. Now that's not such a rosy picture here because it's low. Now if we go and look at multiple years max, then it seems that the max maybe 5 years. So it really started a while ago. That's probably some games, corporate changes, and because there was another D wave. But in any case, I personally going to try to do it because they are working with exactly my use case. Where can I go and find out more about how can I take the mundane, very mundane Texas delivery company and make it one of the quantum computing powered delivery. That is the whole story of this D-Wave, and that's enough about D-Wave. I think I have other things to talk about, so let me do this. Let me stop sharing for a short time and give you a chance to ask questions or your comments. Okay, no questions, no comments, everything is good. So what I will do is I will share the screen again. And with this introduction, I'll go back here and close all the other tabs. And what else? What else is that we didn't pay enough attention to this other book. So that's theory. Now, that was the news. If I can do it like this, then I would say that maybe that is theory, and that really is the news. Old news, according to people who know, but still. Now, that's a book. Now, what's special about this book? Let's click there. There you are. You have this book. It's in the folder. So if you're interested in reading that copy of the book, it is there. And I wanted to show you some of the qualities of this book. That is because, yes, you have the best book called Mike and Ike, but you also have a special person, John Watrous. That is just like Walrus, but Watrous. And he is a teacher, a professor, also part of the IBM since about a year or two ago. And he is a very popular professor at the Qiskit. So seeing that and knowing that there are quite a lot of presentations, now if I click here, yeah, then I wanted to know what's his book about. That's what I showed you. The book goes into math. So if you are into learning about quantum computing from the purely mathematical point of view, that's the one. How mathematical? I'll show you a few slides, but just to see what he's going to do is mathematical preliminaries. He'll start there. Okay, so there are many approaches. Richard Feynman is the famous approach, saying that what's important is the physical nature of the reality, if it exists. But formulas are for our convenience to make things easier. That's not John Waters' point of view. His formulas are the center stage, and I will show you the beginning of that. Okay. Now, where do I get the beginning of that? I'm closing this book, and I'm showing you some of the slides. Now, these slides, I think, are right here, and I will not bother too much about downloading them. Right. Well, I could from here. Maybe I could download. Maybe it will look a little bit better. Let's download them as such. And it will be here in the downloads. And that will be in the course that I will be teaching. That will be the mathematical approach. Now, I say I will be teaching is because I started that all from a course that I taught at Cisco, and then they wanted more, and then they didn't want more. Right now, they said they don't want more, but I'm still continuing because that is really the future. So let's look at this mathematical approach by John Watrous. And he is a wonderful fellow. You can see his lectures on YouTube. And then I see some chat where, okay, what's the computing capacity of 433 qubits? Ah, that's great. Great question, Fred. So when you start talking about quantum computing, you realize that you essentially need to throw away everything you knew about computing and start from scratch. And starting from scratch, you say, okay, in the physical classic computer world, there were bits, and everybody is satisfied. Yes, bits, he knows. But in the world of quantum computers, there are qubits. Okay, sounds reasonable, qubits. And the bits can have a value of 0 or 1. And the qubits can have a 0 or 1 or anything in between. Now, how does it work, anything in between? Well, mathematically, is described by the probability of the value being between 0 and 1. But there is more to this. It's all related to the physical nature of our quantum computers, and the major bit implementation is, let us say, super cold particles that exist in all these states at the same time. And because they exist in all these states at the same time, well, they potentially have all the information of all the Shakespeare books in one bit, in one qubit. So that sounds like theory. Where you go from there is say, well, but if I had 2 qubits, that would be more fun because 2 qubits would allow me to have 2 universes represented at the same time, plus they interact between each other. This is where the power of computing in the quantum world comes from. If you can have 2 qubits and they can interact, they can solve multiple problems. Okay, how many qubits do you need? Well, to solve the RSA problem, to solve the encryption, to break the encryption, you need about 10,000 qubits. Why is that? That is because if every qubit can be in a 0, 1, or anything in between, then 1 qubit can have 2 dimensions, 2 qubits can have 4 dimensions, 3 qubits can have 8 dimensions, and so on. And if you have 433 qubits, then theoretically you can have 2 to the power of 433 qubits. But there is noise and it's not all that easy. And the estimate today is that you can break all encryption when you have 10,000 qubits. Well, it's close because we had 128 just a year, well, 2 years ago, and now it's 433 qubits. I hope I'm answering your question, Fred, that if you're trying to gauge how powerful IBM is, 433 qubits available to everybody at online is pretty powerful. Now, what I just showed, D-Wave, they boast 2,000 qubits. Well, that's even more, but their qubits are more specific. So usually people think of IBM as the leader, much as Google would like to say that they are. but IBM at least positions themselves as the leader. So 433 today doesn't solve all your problems, but it shows the potential to be there in how long? Well, we discussed it. We said that the potential is to be there in 4 years. We discussed it just recently. The potential to break encryption is 4 years. So should we wait for 4 years and then change to another encryption? It turns out no. It takes about 4 years to change the encryption so that it's no longer breakable. In other words, today is the turning point. Today is when we should start bothering and worrying about encryption and about all other things and prepare for the 10,000 qubits or more. Okay, I hope I answered this question. That's an introduction to why people think it's, in addition to all other wars, it's a quantum computing war going on. Thank you. Now, this is John Waters. His view is mathematical, and what he says is, guys, if you want to follow me, him, Waters, you will start with mathematical preliminaries, and you will see that whatever is going on with the particles, photons, who are they? Electrons, other particles, that can be represented by mathematical notions. Each quantum qubit is represented by a vector, by a two-dimensional vector. And whatever you can do with this qubit is transformation. So transformations are represented by matrices. From then on, he leaves the physical reality altogether and just says, follow me into the world of mathematics. And which mathematics? I'm showing you. That's the world of mathematics. So who is it for? Graduate students and researchers. What kind of mathematics we need? Well, he talks about, I'm not going too deeply into this right now, but I will convert it into slides with pictures, and I will be going through these slides when I'm in class. I'll be going through them much more in detail. The end result will be that is what you'll need. You'll need a refresher on the Euclidean spaces, linear operators, and decompositions. I'll tell you in 2 words, that's all very simple. Okay? But going deeper will require a little work. So Euclidean spaces, everybody knows, right? Oh, sorry. Euclidean spaces is x, y, z, right? That's very easy. Maybe x, y, z and another coordinate, and maybe more, maybe even infinitely more. Yes, that's Euclidean spaces. Now, in mysticism, and I need to mention mysticism because anyway, we're in quantum computing. There is an exercise where you imagine a 5-dimensional space. And if you never heard about such things, then 3 dimensions, they come from our physical world. The next dimension is time, and that is before and after, and the last dimension is good or bad. So, and that's enough for the exercise, the mental exercise, imagining that it's enough. But in quantum computing, we have Euclidean spaces, which would not be that bad by itself. But the numbers that live in these ones are complex numbers. That's the key word. Complex numbers, because in physics, you always bump into I, this imaginary number, and e to the power of I, and that blows your mind. How's that? How can you take e to the power of 2? I know that's 2 e times e, but how can I take e to the power of I? That is only explained with the expansion into an infinite series. All right, that's what you will need to know. Another thing you'll need to know is linear operators. That's easier. So if you ever took a vector and multiplied it by a matrix, that is a linear operator. Each matrix will be dear to you because each matrix will mean something. There will be, can you give me an example of good matrix? A matrix. Of course, there is a unit. You multiply by this matrix and nothing happens. That's easy. But I'm trying to remember any good sounding name, transform, matrix, and nothing comes to Toffoli. Okay, Toffoli gate. Right. That would be a transform that you apply to your qubits, and it would have a matrix. So I will try to do it like this. Okay, matrix. That's what it is. Pretty big, but that's real. So we were here, we were looking at the slides, and we were saying if we want to follow Watrous and his purely mathematical approach, and he's not alone. I have a friend who teaches this, and he always tries to get away from the physical pesky reality and goes into that. Well, that's an approach. I'm not saying that that is a must. It is helpful, and it's one of the possible approaches. In the end, I believe that you will have to learn all. But to start, you can choose one of my favorite, or I mean, one of your favorite. I recently saw a couple of friends. They are not physicists. They just don't understand anything at all. But it affects them anyway. So they sit and discuss how is that any kind of indeterminate state is just like quantum indeterminate state. And I'm saying what you are talking is pseudoscience. And no, they say, it affects us. So cannot argue against that. All right, that's linear algebra. And I think we covered the what I wanted to cover, right? That's the end of it. So let's review where we were. We were here, and first we discussed that there are practical applications. At least it claimed here that there are practical applications. Now we'll have to find out how practical that is. And then there is a book by John Watrous, and I showed you some of the first steps that he will invite you to take if you read his book. Okay. Now, with that, I want to stop sharing the screen and offer you a chance to comment, to ask questions, or to say, we want to know more about this or that, or Mark, whatever you choose, okay? But I'll be silent for a short while and let you talk. Okay. Maybe no comments right now. Maybe something will come up. You will always be able to write, ask questions. Sometimes on at least some other webinars that I run, and there are only three. This one, AI, and security. So people come and they present. I totally welcome it. That is the seminar structure. Now I see some comments. Fred asks what Elephant Scale does on the space. First of all, Elephant Scale is an educational company. So we teach. We teach quantum computing, and we teach AI, and we teach security. And I much prefer this. I prefer webinars to a regular class, because in a regular class, I'm always nervous. What reviews will I get? And once it even bit me this way. I was used to talking in a seminar like we are, and you guys know it all. You understand, and the students are not necessarily so. So I kept giving them hints and saying that's how you do this, but they wanted everything chewed up and fed to them with a spoon. So I got the bad reviews then. That's the story. The question is, what does Elephant Scale do there? We teach. But as you may have seen, I also do another company called Skya, and that is where we do whatever we were teaching. We were traveling around the world, at least I was, teaching people how to do all those things that we teach. Now I actually do them, and I'm part of startups, and I'm usually the architect, especially AI, because no startups for quantum computing that I'm involved in yet. But I did promise. I promised it to the legal startup that I often show that, guys, I'll invent the quantum computing algorithm. That's a high bar that I have set for myself. We'll see if it works or no. Does that answer your question, friend? Okay, I hope it does. So I wish you a great week, and I hope nothing will stop us from meeting next week. And I expect your comments. Meanwhile, have a wonderful weekend. Okay, Mark. Yes, and I will surely advertise it. I'm not bashful. I if I have anything to boast, even if I don't, I still do it. All right. Thank you very much, guys. Be well. All the best.